So I cheated a little bit. Actually, stopped the recording for a second. Now let's see if I can remember. So it's switch port. Trunk isolation. There we go. There we go. Okay. So as I said, we want to make this a trunk port. So switch port mod trunk. And there you go. So now pretty much, there you go. Change state to down. It'll come back up on its own. We have two VLANs to create, right? So we have VLAN 10. Let's call that one admin. And we have VLAN 20 to create as well. And let's call that one. So we created our VLANs. Good to go. If we wanted to get really technical here, we would change our Giga Ethernet 01 and 02 ports as well. So let's go ahead and do that because we really should. So our interface Giga Ethernet 01 should be switch port mode access because it's connected to an end device. And our interface Giga 02 should also be switch port mode access because it's connected to an end device. It's not a trunk, right? And so pretty much done on our switch. I really didn't want to do too much more on that switch. Good. So back up to our router. Everything seemed to have stopped here. Good to go. Okay. So how are we going to give the IP addresses to the computers? It's actually pretty straightforward. I'll show you. But I'm going to set up a DHCP, I think. So when we go in the console of the PC, really, we're going into our terminal, right? And so if we want to give an IP address, we have to do it this way. And so IP, and so we're going to put our address in, right? So IP, and there's how you give an address, right? There it is. With a subnet mask. So that's how you'd set it up, but we're going to make these DHCP clients, and we're going to use Dora the Explorer to do that. But first I need to set it up on our router. So let's set up the DHCP on our router. Okay, so IP DHCP, we're going to have to create two pools, right? So one is VLAN 10 and VLAN 10 is admin. So let's call this admin. And the network that we are using, you'd think after all this time I'd be able to type network without looking down at the keyboard. I must have typed network a million times in my life, and I always reverse the T and the W. Anyway, so the network we're going to use here is 192.168.10.0. Subnet mask that goes with it is our 24-bit mask. And I'll set up as well the default gateway. And so the default gateway is going to be 192.168.168.10.1. So that's going to be our pool. I'm not going to exclude any addresses. The default gateway gets excluded automatically. So we're good to go. Next up, I'm going to set up our pool for the other VLAN. So IP DHCP pool, and the other one was called accounting. So let's put an account. There we go. And the network we're going to be using for that is going to be 192.168.20.0 again, the 24-bit subnet mask. And the default gateway is going to be 192.168.20.1. Okay. Pretty much done there. Let's see if I can't get these PCs. Oh, next, one thing I did forget to do. Hopefully somebody's paying attention and corrected me. Oops, hang on a sec. So on my switch, I need to put my ports into the proper VLAN, right? So if I do a show VLAN here, you're going to see that my VLANs are there. There's my admin and my accounting VLAN, but of course there's no ports in there. Everything is in the default VLAN. So I need to change that. So let's put my Giga 01 and switch port access. This guy belongs to VLAN 10. And Ethernet 02. Interfaces. Yes, I am. And so this is going to be switch port access. There we go. So I put my ports into my VLANs. If I just do a do show VLAN, now I can see that those ports are in the right spot. Good. Notice I used the command do. God, I love do. do is a great little command. If you're not in the right spot on the operating system and you don't type do, then the router is going to give you, or the switch in this case is going to give you an error message. Okay, so let's get into my PC. And there we go. Thank you. And so I'm going to set up the IP, and if I'm not mistaken, it's IP DHCP, and I'm just going to do a release to force him to go get it. But let's go take a look. Yeah, so IP DHCP, and then I'm just going to make him renew so that he goes and gets. So -R. Let's see what's going to happen. So he's going through the DDD of DORA. See, it's going through DORA. Isn't that neat how they set that up? And of course, for those of you who know DHCP, DORA is the 4 steps of DHCP, right? And so it missed off on the first D, hit the DORA, and there got an IP address and a subnet mask. So we like that. I will do the same thing for PC2. And we'll do the same thing. So let's make it new. I should go get. And there we go. So far, so good. In fact, at this point, we should be able to ping the other PC. 192.168.2. We're timing out. There we go. There we go. So that's working. Good to go. Okay, so we set up that side. Let's set up our serial interface now. So it's serial 4-0. Again, the numbering of the interfaces might be a little bit odd from what we're used to using in classrooms, but that's how we set this up. Okay, so back to router 1. Looks like I closed him. So let's get up going here. There we go. There's my router 1. Okay, so let's get my serial interface going. So it was 40. The IP address we're going to use here is 10.0.0.1. We're using a 30-bit mask here. I'm going to put a clock rate. Check which side we're on, but let's avoid all problems. Clock rate in here. Clock rate best fitted rounded to that. It's fine. Thank you. And of course, my shutdown to open up the interface. If I go over to my router 2 now, and of course, I've done nothing in my router 2 yet, right? And so there's my router 2. Thank you. So let's bring up the serial interface 4.0 on both sides. And so the IP address that we're going to use over here is 10.0.0.2, the only other available IP address. We'll shut down to bring it up. Hopefully this comes up. And it did. So we're good to go there. So basically we've set up, let me just move this aside here. Come on. So basically we've set up everything. And we're down over here at the Giga Ethernet. So let's set up that Giga Ethernet as well. So on router 2, I'm going to go interface Giga. I think I used 00. Yeah, I did. So the IP address over here is going to be 192.168. Of course, I used 30.0 as my network address. So it's going to be 192.168.30.0, 30.1, excuse me. That mask, and let's bring this interface up with a no shutdown. And of course, I should not be using shortcuts to the actual command, so no shutdown. And the interface comes up, good to go. Let's dynamic trunking protocol should be running on these switches, so we really shouldn't have to make it a trunk on the switch. So let's try without and see how it goes. Okay, so into our PC3, thank you. There's our PC3. Let's give them an IP address. So it's going to be, and we're going to give them a static IP address this time. So IP address. So the command's going to be IP 192.168.30. Let's give them .2. The prefix here is 24. And the subnet mask is going to be 192.168.30. Checking for a duplicate address, which is a kind of cool thing. And of course, it's good to go. And so we've given it the IP address, not that duplicate address. If you're thinking IP version 6, you're absolutely right. It's pretty much where it came from. So we've addressed everything that we need to address. And of course, if you've taken any Cisco courses, you know that we need to look inside our routing table to see what's going on inside our routing table. So let's take a look inside router 2's routing table. The way that we do that is going to be, there we go, it's going to be show IP route. Of course, we only have our directly connected networks. We need to set up static or dynamic routing so that everybody knows about everybody. And so again, this router knows about his, so this router knows about his directly connected networks. Yes, yes, thank you. But does not know about the remote networks. So we have to tell him about those remote networks. Let's use Ospf. So let's start over here with router 2. Let's use Ospf. So we're going to go router Ospf. Ospf process ID is going to be 1 here. Oops, don't tell me we don't support it. We do like Ospf. Did I spell it? There we go. Oh yeah, I spelled it wrong. OPSF. Okay, so router OSPF1. We need to add the directly connected networks, right? So it's going to be network 192.168.30.0. And he wants a wildcard mask, right? So remember some of the operating systems you can put in the subnet mask, it'll convert to the wildcard mask. For those of you who don't know what a wildcard mask is, the wildcard mask is the inverse of a subnet mask. And so where you find a 1 bit, just flip it to a 0 and do the calculation that way. This is the wildcard mask that we need for a subnet mask of 24 bits or 255.255.255.0. The other thing that we need to put in this command is what area does this belong to? We're going to put everything in area 0. Oh, and there's my Giga Ethernet that came up with that half duplex. We got to figure that one out too. Okay, so that's one network. The other network that we need to add to our OSPF is going to be our 10.0.0 network. And there is the wildcard mask we need. We're going to put them in area 0 as well. Okay, let's head over to our switch. Let's head over to this switch. And let's see if I can remember the commands that we needed. Oh yeah, look at this. Oh yeah, okay, so let's head in here. We're on the other switch, so the Giga Ethernet 00. And of course I need to change the duplex, right? So it was no negotiate auto. And now I can do duplex full. Right? Duplex, there you go. And so that should take care of that. Okay. So router 2, we did our OSPF. Let's head over to router 1 and do the same thing. And so router OSPF, this time, don't make the same mistake twice. We'll use a process ID of 1 again. And so network. And so there's going to be 3 networks over here. There's 3 directly connected networks. And so 192.168.168.10.0. Wildcard mask that goes with that 24-bit prefix to that. We also had the 20 network. So let's cute a little bit, use the shortcuts. Of course, the last one is going to be our 10 network. If we've done this properly, it should come up relatively quickly. Okay, let's see if we're going to be able to create an adjacency here. Yeah, we have. Look at that. So a new adjacency has been formed between our 2 routers. Theoretically speaking, we should be able to ping everywhere, but let's take a look at our so if I was to do a show IP route, just to show you that to do command, so show IP route, it gives me invalid input. I'm not in the right spot of the operating system to do this. So by adding the do, it's going to allow me to type any command anywhere. It saves me from exiting, not more than so show IP route. There we see our 30 network in our routing table. And so if I go over here to PC1 and I try to ping the other PC, I gave it 30.2, I believe. Let's see if that's gonna, yeah, and it's answering. So we're good to go. So our packets are going back and forth. We really like it, working well. I'm telling you, once you get the configuration, once you get the installation of GNS3 working properly with your VMs and everything, it really does work very well. It's a really cool product. Okay, so that's up and running. Let's head back into the routers and let's change our routing protocol that we're running. Okay, so let's set up EIGRP. I really like EIGRP. EIGRP is a proprietary protocol. We're not really supposed to like it, but I do. So let's go EIGRP 10, and let's go network. Let's add those directly connected networks again. 10.0. Let's see if I can get a subnet mask. No, still wants a wildcard mask. So a real traditional operating system in here. So that's our 10 network. We need to add our 20 network. And we need to add as well 10 between the routers. Here we go. Notice that we're not putting an area here because our autonomous system number is in the initial router EIGRP command. Here. So router EIGRP as well. And so let's go network. 168 is going to be 30.0. Oops. And our 10 network as well. Let's see if that comes up. And it did. So again, we have our neighbor change, EIGRP is up, so we have a new adjacency. So now we're running two routing protocols on in the same network. If I was in class, I'd ask somebody to tell me which one we find in the routing table, but we're not in class. I had to record this in advance. And so there's nobody to ask the question. So maybe somebody in the background can ask the question, Andrew, which routing protocol is it going to be running? Well, that's a really good question. I'm glad you asked that question. And can anybody answer it? I think it's based on the administrative distance. Exactly, it is based on the administrative distance. You're absolutely right. And so if I take a look at the routing table now, let's show IP route, I will only find EIGRP. And so why is EIGRP the routing protocol the router is using? Because it has a lower administrative distance than Ospf. Naturally, Cisco's operating system prefers its own routing protocol. And so the administrative distance is 90 for EIGRP, it's 110 for Ospf, and that's why we see EIGRP in our routing table, and that's what we're using. 12:49, I think I'm pretty good on time. I think I did this in the time that I was allotted to do it in. Again, if anybody has any questions whatsoever, please feel free to send me an email. Of course, you can send me a mail. There's my email address. There you go. There's my email address that you can use if you want to. And if you're searching for me on MIO, then it's just search for Andrew Golden. I'm the only teacher at LaSalle College for Andrew Golden. By all means, send me a mail, and I'd be happy to help you out with whatever I can do. Okay, good. So everybody, I hope you enjoyed this little demonstration installation of GNS3. I hope you enjoyed as much as I do. As I always finish, peace and love, everybody. Be good. See you all soon.